titled Every Connection Counts. With around 30 years of experience in the electrical interconnect industry, Mr. Suresh Kumar has performed in various roles in the product development and manufacturing management within the current aerospace, defense, and marine business. Now, I would request Sir to deliver his speech. Over to you, Sir.
Thank you, Swami. I'll just share my.
An antenna that opens a home to the Internet of Things. A contactless connection that transfers data and power through air. A sensor that sets the future of connected cars in motion. At TE Connectivity, these are the small but vital parts of your brilliant ideas. Around the world, over 7,000 TE engineers are collaborating with you to solve your toughest problems. We're using aluminum in automotive applications to reduce wire weight by 49%. In data centers, we transmit 400 gigabits per second while using significantly less power. And we're allowing your innovations to work in the harshest environments. From 11,500 feet below sea level to the surface of Mars, and everywhere in between. Whether it's hot, corrosive, or pressurized, our connectors and sensors can be used in everything from oil rigs to fitness trackers. Our components are in virtually every vehicle, making them safer, greener, smarter, and more connected. We're working with industry leaders, and we're partnering with a new generation of innovators to bring their ideas to life. At TE Connectivity, we know that true innovation is possible only when it's in close collaboration with you. Let's create something brilliant together.
Hope all of you were able to hear the video. Hope you enjoyed it. Let me know once you're able to see my presentation.
Yes, sir, we are able to see it now.
Yes, sir, we are able to see.
Yeah, good. Good morning, all of you. And first, I would like to thank Swarupni for giving the warm introduction. Before I get into the presentation, I would like to thank each one of you for taking your time and showing your curiosity to be part of this webinar today. TE Connectivity believes every connection counts. Today, I would be part of you to take you through the world of connectors and interconnect solutions. So in today's agenda, we would cover, I'll just give you a company overview, interconnect technology, future trends, case studies, and applications. And feel free to stop across if you have any questions to be asked. Let's have an interactive sessions as we progress. And we also have a question session at the end of the program, so feel free. And I would like to know everybody, is it audible and clear?
Yes, sir.
Okay. The purpose is we create a safer, sustainable, productive, and connected future. That's the purpose of TE Connectivity, which gives the solutions across. And we are a 13.4 billion company, which makes around 270 billion products to address various markets like communication, transportation, and industrial, which is a subset of appliances, data and devices, automotive, industrial, transport solutions, aerospace and defense and marine, and medical equipments, and energy. So we address the entire market with 270 billions of product which has been manufactured or yeah. TE Connectivity is a global company. We have footprint manufacturing sites, more than 110 locations. We have an employee strength of close to 80,000 people. And we stay close to the connectors across, connect customers and supplier requirements across the globe. We are present in more than 150 countries across the globe. TE is a technology-driven company. If you look at it, we have close to 15K patents, and we spend close to 640 million towards research and development. We have 8,000 plus engineers, and TE is one of the company which spends close to 20% of its revenue towards new product development and technology. I take the privilege to say that we are one of the top 100 innovator company as per the Cavalier Analytics, and we are also identified one of the most admired companies of 2020 by Fortune Data Analytics company. So TE spends, or products which creates by TE are having an engineering solution in each of the product, which I will just take through as we progress in the session. TE uses a TEOA culture to develop products which will be optimizing on the quality, service delivery, and customer supports. TEOA is nothing but TE operating advantage, which is something similar to the Toyota's GIST and Six Sigma and all those things. It's the integration of all those things. TE uses this technology to develop the products, process, and meet the customer demands and challenges. Apart from making a business a profit, what do we do back to the society? It's a society return back to the society is not only the company's contribution, even the individual employees contribute to the society. Company has spent back close to $5 million towards a charity, and 36,000 employee hours have been volunteered. And we also, any product we create or any factory we set up, we ensure that there are some of the green energy requirements have been addressed. Over the last 20 years, we are able to bring down the carbon content by 38% and water saving by 30%. So we are also endorsed as one of the ethical company by Ethisphere. We have got this for the last 3 years in a row. TE addresses the connectors and interconnect solution across different segments like aerospace, appliances, automotive, commercial and transportation, data and devices, energy, medical, oil and gas, and sensors. Most of our products are for harsh environmental applications, and we have 87% reliability on the products what we sell across the market. So I'm sure that this would excite you to see that our product is across in all the markets, and in the video also you saw that the products is used in different application technologies, and we work together to deliver the products. We are committed to a safe, diverse, and inclusive work environment where we create a collaboration, innovation, and innovation flourishes. So TE is a company which works on a global presence. For example, in India, we work for global projects like Airbus, Boeing. Same way in automotive, we work for BMW and every Formula cars. All those things from India, engineers work across for the global platforms. So it is not that in India we work for India customers. Apart from that, we also work for Indian DRDOs, TVS, or Marutis. So we are a global company where we share the knowledge, we interact with each other, so that we bring in the latest technology across the globe, anywhere we are, to the market where we are flourishing. Globally, TE is a 75-year-old company which has brought in a lot of technology to the market. During the World War, the main challenge was to how quick we will be able to service the product and get back to the battlefield. So that is where TE, the earlier known as AMP, brought in the technology called crimping technology. We were the pioneers to bring in the crimping technology to the market, Today you see every product is being crimped and used. If crimping is not there, we have to go for a soldering in a battlefield. You need a power supply, you need a heater, and all those things. If you have a crimp, it's a simple device. No supporting service is required, which you will be able to address. Similar way, if you take in the battlefield, if there's fire in a ship, you see that a lot of people die. It's not because of the fire or it's not because of the temperature people die. Most of the people die because of the smoke which gets generated out of the wire. That is the key thing. If you particularly in a ship, you are entrapped and the smoke gets generated. So you have PVC and other cables. TE is pioneered in developing new technology, new products which would meet to the requirements. Similar to that, even today we have a company which is old enough from the World War II. It's called the Rochester Cables, which makes underwater cables which connects across continents, and it is all neutral ion cable. So it floats in the sea, so it's able to terminate, and then we do the termination and laying of cable subsea also. So these are a few. Apart from that, if you see the latest, we are into the medical domain. We make cathedral cables and all those things. Data everywhere, you can see our presence. Being a 75-year-old company, how good are we in India? In India, we are 25-year-old, and we have close to 4,000 employees working in India. Head office at Bangalore, and we have multiple manufacturing locations across Bangalore and in Pune, and the design centers for are mostly in Bangalore. And we have sales and service support across India, close to customers. Any questions, or can we proceed? Is it clear?
Yes, sir, it's clear.
Yes, sir, it's clear. We can
Yes, sir,
just
it's clear.
Okay. So let's move to the interconnect solution part of it. So this is what happens if your interconnection is poor or you are not able to get connected properly. I'm sure that all of you had gone through this frustration in some way or other during this pandemic period, working from or taking your classes from home and all those things. Am I right? You don't get the connectivity, your screen goes blank, your audio is not clear, there's a delay. I'm sure that all of us have this problem. So why connector? What do you think you can do with a connector or a sensor? Power to engineer something bigger, create a safe and sustainable future, optimal performance of all the connected devices, improve response time, and improve performance capability. So with all these things, you can keep you connected. So that's the power of a connector. So it also essential to enable different utility network, life-saving medical care, global communication infrastructure, connected, commuted, and transportation network. So that is what creates the main thing in this. So it also keeps people experience healthier and enjoyable lifestyle. Don't you agree that connector is one of the key things in everybody's life to get connected across the digital era? So from the connector, how complex is an interconnect solution? I'm sure that everybody would have seen a wire connecting multiple systems, multiple domains, multiple application. So I just thought to bring in the complexity which goes into the wire, where we see on the outside a black jacket, which forms the interconnect solution. So right from the braid, each one of it has its own application. The braid, the repair products, molding products, conduit, feed through. These are all terminologies for different products which we are trying to use it across. Contacts you may be doing, terminals you may be doing, connectors you'll be knowing, wire and cable, fiber optics. These are the few products which you may be knowing, and few of the things you may not be knowing because you're not into the product by itself into the detail. And I also don't expect everybody to know it. So as the product develops, as the technology grows, the complication increases. If you look at it, the day when we had the 1G, 2G, where the data rate was very slow at 64 gigabits, today we are at 1 gigabit, which is the thing. So how can this happen? Or what enables it? It's not only the PCB design or IC design which could be able to get out of this to individual any one of you in the houses working comfortably today. If we had 1G or 2G, do you think today we would be in a position to address or work during the pandemic time? It would have been a clear lockdown, or it would have been a total mess. Today we have a technology which is able to support and ensure that the world keeps moving in spite of having a big pandemic. So that is how we are able to support the 5G technology which we are in today. So in this seminar today, I'm sure that everybody, there would be a different expertise sitting in, which would be developing products in different regions. It could be either it could be a PCB, or it could be a system, or it could be a subsystem, or it could be a connectivity between the buildings, different floors of the building, or it could be between two buildings or two regiments or something. So you'll all be growing to that level. So when each one of you are expertise in one of the area, how do you ensure that the data which is generated on an IC which has a good competency or developing a processor gets transferred data or move the signal to the next level of the PCB to process the next variant, and from the next level PCB data processing, it should go to the outside to the next system, like for example from the CPU to your monitor or to your overhead screen, or I'm just giving a live example. Even in an automotive, today every automotive systems are becoming electronic. 10 years back, there was very less electronics in an automotive car. Today, if you see, most of the things are automotive in an automobile. If you don't switch on, your steering also doesn't turn. So that's how the technology or electronics is getting added into it. So we need to support system of wire and cable connector, which should be able to the lifeline which connects between systems, between PCBs, between buildings, between subsystems should work. So just to give a pictorial representation of, you can see that between two PCBs, you can see some connectors here. These two are connectors which gets connected, and then from this PCB you have a cable which runs through it, which gets connected here, and then through these connectors, we have the connectors which you see here, the output gets flown. So you have different types of connectors for different application. This is something like your tank which is full of water. Unless your outlet is in a position to handle it, you will not get adequate water outside. So that is how good is your design inside. Unless your connectivity and interconnect systems are defined well to the requirement, to the market, to the application, then only it will meet to your requirement. Hope I've made things clear at this point. Any doubts, any clarifications? You can note down, we can discuss at the end also, or you can stop wherever you want for any questions. Okay, so how does the interconnect solution progress? So it starts from a connector. The connector gets, which I'll explain what is a connector in detail, and it gets connected to a wire. From the wire, it gets devices. Device is nothing but interconnect system between the wire and the connector contacts, and then You have adapter which holds it, which is used for rework, repair of the connector during the services. And then you have a shield. Function of a shield is to ensure that it grounds. There is no EMI, EMC. I'm sure that every one of you would have addressed that when you take a phone near your laptop or to your TV, you will see a distortion. If not in the latest TVs, the older TVs, you would have felt that. So that is all because of there is no EMI, EMC shielding between the two equipments. And then how do you terminate the shield to the adapter? It is using a terminal. Then you have these shields are metallic components. It has to be covered with a jacket, so you have mechanical protection. And then you have a strain relief to take the load. And then that's how the whole system gets connected to form the total interconnect solution. So there are multiple stages, multiple processes which gets added based on the application, based on the requirement, which is not understood outside when you see as a cable or interconnect solution. I've just taken this opportunity to explain what is a connector. No two connectors are same. Even though it looks same, circular, rectangular, form factor looks same. The internal integration construction of each of the connectors has a complexity which defines, which has a criticality of it. So the size form factor has a critical role to be played in the connectors. So I'll just walk you through the parts of a connector and explain few of the criticalities and the technology which goes into in getting into a product. For example, pin of a contact. This is the main thing which connects between a plug and a socket. So we have a pin, and as well as the mating side we call as a socket. So that is a technology which we speak about. A machining process is there, your dimension finish is there, surface finish is critical, and there is a plating. So all these things contribute to your performance of the product. One is your design. What is the distance between two contacts? What should be a diameter? What should be your engagement? And what should be a surface finish? What should be a plating of the connector? So each of those things will vary, and this contacts will vary for power, signal, RF. So everything has a different pins or contacts. So no two products are same. No two contacts are same. Moving down, we have a grommet. Grommet is basically used for IP rating. It is made of silicon rubber. It is a molded item. And so we get an opportunity to learn about silicon rubber, soft material which can be used here, which will take care of your temperature, which will take care of your IP requirements. Followed by that, you have an insert. It's a plastic material. It is basically used to hold the pins or socket in position. That is a function. It is not only that function. That has a technical requirement also. So if you take as an electrical, breakdown voltage when you're talking about. So when you between two contacts, if you apply a voltage, the plastic should not fail. So that is critical. If you're talking about a signal integrity, high-speed connector, this material plays a critical role in signal integrity. So it will not be the same plastic, same colored material which is used across for all the industry or all the connectors. It varies based on application. So we work closely with the material suppliers like GE, Bayer, and all those companies to develop plastics which would meet to the specific application requirements. So that's a technology we work across to get that. Then you have mechanisms have a ball, locking ball, spring, and clicker disc. These are all circular. These are all different technologies, different ways to hold the connector between the plug and socket, and also to ensure that when it is used in rugged applications, like it is a defense battlefield where you're using a connector, or a Formula One racing, you're using a connector which goes through extreme endurance, vibration, shock. thermal, all those things. It should not get opened out. If you see in a normal house, whatever you're using in a USB connector, there is no locking. You just pull it, comes out. So that level of connector cannot be used in highly reliable and mistake-proof environment like battlefield or in Formula One racing and all those things. So we need to give a mechanism to lock in position. So all these things becomes part of a connector. Then next you have the coupling ring. Today you have a stainless steel, aluminum, which is a metal. So this will enable you to connect with your adapter, which you saw in the previous, and then connect to your enclosure, which is a metal. So your grounding, EMI, EMC, all those things takes place. Today, because of the weight factor, we are looking in to move into a plastic. So does plastic conduct? No, it doesn't conduct. So how do we make it conduct? So there's a technology which goes in. How do you make plastic conductive? So if you want to make a base plastic itself a conductive material to take the coating, so then you have to work with once again with the material steel. So that is another technology which goes into it. So like that, and you have RFI spring. This is a beryllium copper or different material, and these are all cost sensitive. And you have gold plating on these contacts. How do we optimize on gold? Today, gold is a rare material. So how do we find an alternate to gold? So these are the technologies which goes into it. If you look at a simple small connector, which would address machining, it would address molding, it would address plating, or it would address sheet metal process or coil forming, all those technologies which goes into it. If you look at materials, you have steel, aluminum, copper, brass, silicon, rubber, plastic. So it is such a small connector. If you are working in, you get an opportunity to work across multiple materials and multiple technologies to deliver a product. It is not that a simple connector as we all think through. Before I also got into this industry, I thought, what is being a connector? And I asked this question to most of the new engineers who joined this organization. What do you think when they join the first to the company? What is that? They all give, it's just interconnect between two parts. So this is the technology which goes into it. So this is the total industry which gives you a total exposure of all the process and all those things. So what is the challenge we have? Today we all are working about smarter solution, lighter weight, faster speed, and more power. So SWAP is a buzzword in today's industry. Any industry you go, either it is a space, or it is a aerospace, or it is a automobile, everywhere. So you reduce weight, what do you get? In an aircraft, if you're able to reduce weight, you add a passenger. You add a passenger, you get profit. So if you get a profit, so that is what is the advantage you get in an aircraft. What happens in an automobile? In an automobile, you will have a fuel efficiency if you are reducing your weight, if you are reducing your connector. So that is why SWAP is the buzzword across the industry with respect to any product. Whether any industry you take, SWAP is the buzzword. The next thing which I would like to touch base is on, all of you would have seen a cable which is black in color, right? A final cable, either you use for your USB, or whether you look at going for aero show, or if you're gone to a marine product show, or if you're looked at cat cable, you would have basically see a black color jacket on top of it. Everywhere it looks black, but there are a lot of technology which goes into it in developing the product. The application which we see, transportation, as we call it as a system 10, works at 125 degrees. Whereas when you look at aerospace application, we call it as system 200, it works at 200 degrees centigrade. So even though everything looks black, but it is not the same material, same technology. So every application, if it is for a defense, we call system 25. It is at 185 degrees centigrade. Same way you marine, it's called zero halogen, because as I said earlier, this has to be low smoke, zero halogen, so that if there is a fire, the heat should be the first one which is impacting the soldiers or anybody. It should not be the smoke. So that is why each of this has a standard which is defined for a space you have a low outgassing. So any of the component which goes into the interconnect solution, whether it's a heat shrink, tubing, molded parts, adhesive, wires, everything has to go as a sink. You cannot use a system 200 or an aerospace wire for a transportation. It would be a overspec. You will not be cost effective. You will not buy a product. At the same time, you cannot use a transportation product in aerospace. It will not meet the temperature requirement and the other requirements. So it's going to fail. So every product, even though the color form factor looks same, there is a technology which goes into it. It's not only what you see black, it's all the same. So how do we get that? Also, I'll just go through it. Okay, we also have something called, to meet the demand of the market challenges, something called heat shrink tubing and boot. So if you see the image where my point is, this is how it is molded. After molding, we expand it. This component gets to this profile, what you see here in the middle. So this why we make to this profile is when we send to the shop floor for assembly, the wires will be able to assemble easily, go through it, branch out, whichever wire has to go to respective thing gets branched. Okay, here you see 4, and here I'm just getting an image of 3. Okay, and this gets branched. Once you heat the same cable with the wires inside, it will take this profile. You can see here. So we call this a transition. So it will take this profile, and it also inner layer of this has an adhesive which will seal with the tubing. So what happens? You get a rigid IP solution at this point. So even if you drop in water, nothing happens. So that is the reliability of the product which we have. But are we going to apply this everywhere? No. If it is inside a enclosure, are we going to use this technology? No, we will not be using, because it doesn't require an IP, because your system is going to take it. But whereas between two systems, between two shelters in a battlefield, it is going to be these kind of ruggedness is required, because somebody is going to lay it. And there are some cases that your blades are strong enough that even if a truck moves over a battlefield with the mud on top of that, you lay a cable and then the truck runs over it, it doesn't get cut. Okay. And since I'm from Aerospace Defense and Marine, most of my examples will be from the aerospace and defense background, but the same thing is applicable. Today, we work on similar products for Formula 1 cars, because the quick changeover reliability, the Formula 1 cars needs a very high reliable product. If you look at the cameras on the top of the Formula 1 cars, T supplies those things. So it is not only the product which is being made for defense is not used only for defense. We see due to the harsh requirement and reliability and repeatability, people are looking to use in multiple domains also. So this is a critical product. So this is what we say. So T, we call that anything we heat, it shrinks. So we have something called titanium alloy rings. Even that, when we heat, it will shrink. So that's a level of technology. It's a metal component, titanium alloy. Even that chemistry is made in such a way that when you heat that, it will shrink. So that is why we say anything you heat will shrink in this particular product range. Moving to the wire and cable. So as I told you, if you see the image also, the fire happens in a ship or a submarine. It is the smoke which kills the people. Even the recent you had, in 2 years back, we had a marine accident in Mumbai, where one of the ship caught fire. So the result shows that the smoke is one of the reasons. So if you see the rubber and PVC or the jacket material which have been used, T has developed a low smoke, low fire, zero hazard cable, which is becoming part of the defense standard. So this will ensure that even if there is a fire, there is a low smoke and low fire cables are developed, which with the improved mechanical toughness, environment performance, thermal fluid resistance, and all aspects of. So fluid resistance, why? When you lay it on a ship or any application, you will have all the chemicals and which has been spilt over. That should not react with the insulation material and damage, create a shock. So that is why it needs a fluid resistance. Each of the application, there are defined fluids which has to be tested, which we all test through and then qualify the products to mill specification or European norm specifications or automotive specification or IEC specification. Each of the product which gets developed goes through different qualification methods before it comes to the market. So if you look at this image here on the left side, so there is a 1 mm thick wall cable, which is of a rubber insulation, which has been developed and engineered to a 0.2 mm wall thickness. Okay. So I'm sure that if you had observed in the latest electrical industry, home appliances, home wiring, which currently we are using PVC wires and all those things, people are going for a cross-linked cable. Why? In a conduit which is used in the building to connect between your switches and multiple utilities, they are going for a cross-beam cable. When you use a cross-beam cable, like for example, the wall thickness gets reduced. For the same number of contacts or number of strands or AWG of the wire, the overall wire diameter reduces. So, and then this will also improve your mechanical toughness and environment. So it is catching up in the home appliances industry itself. So it will give you a safer environment. If you see the good big builders are using such cables, it is available in the market. You can explore that. This is a technology which is moving, which is being developed for a defense application. It is moving to a consumer requirement, as everybody are becoming more conscious on safety and other requirements. How is the technology growing in the wire and cable? Today we have a copper conductors with a silver and nickel coating. So what is the future, what we are looking at? So now we are moving from aluminum to nano strands with a copper cladding. For nano, we are yet to find coating, but for copper cladding. So when we move from copper to aluminum, silver, nickel to copper cladding, so we also have to ensure that the product what we develop should be in a position to use by the end customer. So what is required? So we need a crimping tool. So the technology to crimp copper will not be same for aluminum. So there's a different technology used for crimping aluminum. So we develop crimp tools also so that the customer will be in a position to use aluminum with a copper cladding because of the requirement of weight. So how do we get a thin wall thickness and improve ourselves? So there is a chemistry which is being worked on cross-linking. This is a polymer which works on. So this bonding is at random. When you do a cross-linking, this gets self-aligned. So the net result, what happens is because of the co-bonding between the different cells, it gets realigned and then it becomes tougher. And with the smaller thickness, you will have a higher performance. It's extruded. After that, it is E-beam, electron beaming is done on the jacket material. So any cable cannot be cross-linked. There are specific materials which only can be cross-linked. So what is the result of cross-linking? You get a higher temperature performance, short-term thermal overload, physical toughness, resistance to fluid, smaller size, low cost and performance. So not only that, so we also work on polymer chemistry to increase the flame resistance, physical toughness, low smoke, and low cost and performance level. So it's a combination of both has helped us to develop the cables, tubes, transitions, and all those things. So what is the result of all this work? So this is how the old cable industry was there. This is a real harness of a MiG aircraft. So resultant of this is what you see here. The resultant of technology which is gone in is what you see here. What does it give? It gives a reliable product. It gives it improves your efficiency of assembly into the system. Your turnaround time reduces, and your aesthetic improves, and repair and maintenance becomes easier. So this is the of whatever you see in the connectors, tube, brace, jackets, all those things put together. This is what we get into it, including the marker sleeves and each of the wires. You will know from here where there's a wire goes here, or this wire comes all the way to here. Everything is marked within this individual markings on all these things. And these are all the jacket materials. Here you can see the transition. So you can hear multiple branch outs. So depending on the application, it has been done. So you see the total transformation from your left side image to the right side image. So these are all the advantages which we bring in. And today I see this is being used in most of the automobile industries also. The other area where we see a big change in technology which is happening is the fiber optics. And the fiber optic cables have been there for a long time, and it is used both in multiple industries. In telecom is the highest user of fiber optic cables, and now it is slowly catching up in the other industries also. So for RF over fiber is a converter which modulates by radio frequency signal and transmitted taken over an optical fiber link. So what is the advantage you get? You have a lower attenuation, larger bandwidth, immunity to RF frequency, easy to install and maintain. So what in total what happens? So when you use a copper cable and you want to transmit from one building to another building, you might have power lines running, you may have EMI, EMC interference, there may be a lightning strike. All those things can impact your cable. So when that happens, your shield or a braid, whatever you have on the cable gets carried and it goes to the system. So if it goes to the system, it could damage your PCB if it is a lightning strike. If it is a EMI, EMC, from one system, when you move to another system, the data gets distorted. So to overcome all these things, if you have a fiber over converter, so what happens is it converts your radio frequency signal into a light energy, and then it gets transmitted. So when a fiber moves, no EMI, EMF interference will be there. There will be no lightning strike because it's a plastic fiber which runs through it, or a glass fiber which runs through it. And your weight of your product gets dropped down, and your installation time drops down, and then the repeater is the only thing which you need to have it. So if you see here, easy installation. So main transmitters and receivers are on the two extreme ends, and only you have small repeaters which you need to take over it. So that is how the technology is moving from, and it is also from the device and datacom, it is moving to the other industries also, fiber optic, with the RF over fiber technology coming into it. And it can also, multiple wavelengths, it can be mixed and sent across and then decoded at the other end. So this helps to carry bigger data and vast. So when you use a fiber optic cable in a smaller enclosure, the challenge is you cannot route a fiber optic cable like a copper cable. You cannot bundle it and put it inside. There are minimum design requirements in a fiber optic cable. If your bending is more, your losses will increase. So we define any fiber optic, you do a design, we say a minimum bending radius. So when such things happens, as today we are all talking about smaller, smaller, smaller. So your existing cable will not be able to meet to your challenges. So we are coming up with the printed fiber optic circuit cable, so which will be able to demand the routing issues. We have up to 6-level fibers. You can go up to 12 layers. So it can take the bending radius challenge. It can be both with single mode and multi-mode. I'm sure that everybody will know the difference between a single mode and multi-mode. Single mode is basically used for a longer distance transmission, and multi-mode is used for a shorter distance transmission. And more multi-mode is used within a shorter region, whereas multi-mode is used between few kilometers also. So any doubts, any you would like to have any thoughts at this point before I move to the future next part of my presentation? Hope it's interesting, fascinating for you, makes things exciting.
Yes, sir, it surely is interesting. We have a lot of information to process. So.
Okay. Yeah, I'm sure that it's a lot of things within a short period of time, which I'm just trying to share with. But it's the technology and the complexity which I just thought bring it to you people. So no connection is simple, which most of the time we feel that it's just two wires, two cables, and two things which just gets plugged in. Okay, so moving to the next part of the thing. So as I said, most of my references with respect to the defense. So what is happening in the defense industry is new combat system set to conquer the future with new connective opportunities. What is happening? The battlefields are real, like a video game it is becoming. So one which you had seen earlier in the video game playing and trying to visualize, seeing the opponent through a smart device and all those things is slowly becoming a reality. So any sensors, anywhere to shoot, tactical and multi-domain combat operations, networking every soldiers and integrated devices, weapon equipments, and then helmet mount, heads-up devices, display devices, and then integrating with your strategy unit, and then giving continuous information supply across from the field to the strategy place to take decisions. So there's a clear, seamless communications and in networking happens across today in the battlefield. So everybody are well connected, and as we see, as this happens, earlier it was used only a walkie-talkie to talk through. Today you have an image which is getting processed. So you need a higher data rate and higher bandwidth to get connected with this. So because of that, it becomes a real challenge to address that. So what is happening here? So slowly everything is moving from individual squad, it is going to an adaptive squad architecture. Earlier it was an individual isolated thing which was worked out. It is within a small networking it was done. Today, but of the technology and the data which we are able to handle, we are able to link between the two squads. And we are also able to interconnect on a larger scale. So what is required? Optimizing the swap for the soldier. So today he has to carry a lot of gadgets, data analyticals, and ML design of, and it's all used in a rugged environment. So what does this happens? So you have to connect a battery, cable, devices, and all interconnects and with the other soldier components. So this becomes increased number of sensors and compound design enabling the soldier wear whatever he's wearing it. That also increases. Host of antennas, sensors, interconnects, wires, cables are all getting added. So when all these antenna sensors gets added, you have to have an interconnect and a reliable solution. So what is in for T, or how the industry gets geared up for? So earlier it used to be a connector which would be threaded one, or which will have a lock clip to have the mated connectors together in position. When somebody runs, it doesn't fall out and all those things. So there's a standard which gets defined. So this is called a quick disconnect connector, which you see here. This also follows some industry standards. So every competition will be able to manufacture. So this is a new technology. So every warfront, everybody will be able to disconnect from his helmet, from his jacket, all those things, and move forward faster. If something is not working, to disconnect and then reconnect to some new technology. So that is how we work and we get into it. Same way on the data speed, also data speed and the power over data and the cables. So there also a lot of technology goes in 1 gigabit to 10 gigabit data rate, frequency over 750 megahertz, designed to support high frequency and speed, qualification for 200 or 100 Mbps. So the new connectors which we develop. So if you see here, this is a plastic enclosure with the plating. This is a new connector which you see here. So this will be able to, because every soldier has to carry a lot of equipments. The more the lighter it becomes, he'll be able to carry more, and then he gets more connected. So that is how we support each of these equipment. So if you see today, a soldier, he has so many things to carry. A helmet with the mounted camera, helmet with the display, a body mode sensors, then headset, radio, GPS, battery pack. So all those things has to be interconnected. So he has a composite enclosure, embedded antenna, compact connectors, wire and cables. All those things has to be taken through this swap, has to be addressed, so that he will be able to carry more ammunitions, and so GPS which helps him to track. So this has to be all these connections and interconnection has to be rugged. And for him, it is only a life or death which he is going to get in. So the product what we develop and give also has to be to that requirement. So that is very, very key in this field. Okay, and signal pair is one of the example or a case study which I'll just walk through you. A single pair Ethernet. Today, if you see any Ethernet cable, you have 8 wires which runs through it like this. So that is basically 4 pairs of wires which run through it. The new technology which is being common is with 2 wires. It's a single pair. So 2 wires rather than 8 wires. So what it makes? It makes smaller, lighter, and smarter. So your connector becomes smaller. The number of wires which runs through becomes reduced. So what is in the other segment? So you get 70% of the weight savings it gives you. So it gives you a broader bandwidth to connect to a in-flight entertainment. You can see multiple things getting today. If you see number of channels have increased in your aircraft, number of connectivity has increased, and these are all because of so instead of 2 wires, instead of 8 wires, you're carrying with 2 wires. So if you add 2 more wires, you will be able to carry more data. So you're able to censor, connectors, heat cabins, light controls, and all. From 100 gigabit, we're able to move to 1 gigabit with this technology. So coming back, this also addresses on the swap. So smaller devices, lower installation and weight. What is the takeaway? The connected aircraft starts with a fewer wire. So that is the advantage we are getting in with. So there is another platform or area which would ensure that all of you would be excited to look in as a solution for urban air mobility. So we have products, there is technology which is there, which goes into it and all these things. I recommend every one of you to go through te.com, look for urban air mobility, which you will see a video which talks through about it. So because today, if you see, drones are distributing, Amazon is using it for distribution of parcels. Whereas this, we are looking at transportation of people from one place to another, 2 or 4 people. So that is the technology which and how we are supporting and how industry is gearing up to address these needs. I request people to go through this te.com and then see urban air mobility. You get more details on that. It is not enough to have a great idea. Innovation happens when customers sees the value in the solution and will ultimately apply the solution. So unless you make the idea into reality, then only you see a product. So how do we do that? We identify opportunities, we take up challenges, we create a solution and turn into reality. Unless you complete the full cycle, then only you say your product, you have done an innovative product. Your idea is always an idea, unless it becomes a reality and a customer should use the product, then only the full cycle gets completed. If it stops anywhere in this chain, then it cannot be considered as an innovation or a good idea, unless a customer has to use. How good your product is, if there are no takers, that means there is a gap. Unless you find what is the gap and address it, it could be an overspec, which today's technology or industry may not be interested in it. So you should know what is required. Voice of customer is the key in any of your development or any of your innovation or anything which you're working on. If you have to really convert an idea into a product which an end customer, or you should be an application which somebody will be able to use it. Who are our customers? We have an endless list because we work across multiple domains. So that's the reason I couldn't put that. Whoever needs enabling a data, power, and signal are all our customers. If I really look through it, all of you who are being part of this seminar are also our tier 2 customers. You get a laptop, you get a mobile phone, you get electronic gadgets. Everything there is a connection. Either it's even a headset which is connected to your laptop, there is a connector. If you have a SIM card, there is a connector. You take anything, there is a connector. So wherever you need to enabling a data, power, or signal, we are there. So that's a list of customers. So I have not put that. And T has an unmatched connectivity portfolio. So whatever I speak more on the connector side, harsh environmental connector I spoke, and I touched upon wiring cable. And we have solutions on ceilings and protective devices, which I have not touched upon. There are sensors, relays, high performance relays, we have antennas and fiber optic cables. These are all few of our portfolio products which we have, which we integrate together to give a total solution to the customer. So as I told earlier, we are there in the whole industry, aerospace, appliances, automotive, medical, oil and gas, and sensors. So across the previous slides, you saw the products and the industry. We work together to give a solution. If data, power, or signal moves through it, T connectivity connects and senses it. Any questions? We can have a discussion. Feel free. Open for questions. Yeah, you can feel free to ask, or I've just come to the end of the thing. I don't know whether it's overloaded or people have not got anything, or
Sir, what type of coating would you consider the best for the performance of any connector, sir?
what type of?
Coating. like plating, like what kind of coating should be the best for any connector, sir? Like
See,
either it's a nickel or silver or what, sir?
see, okay. So see, nickel, silver. So three things which we really need to look into it. What is the application? Okay, and there is no rule that we have to use only silver or gold or nickel. So one is you see, for example, I'll just give you a simple example. You take a SIM card connector. If you look at it, your usage of that SIM card is going to be very less. Okay, so we just give a flash of gold, just a flash. But whereas if you look at your other connectors which you're using for your day in day out cable which you're typing, removing and putting, so it goes for a higher endurance. So we give 20 to 30 microns, whereas coating of gold. Whereas the same industrial connectors where price is very sensitive and your data rate is going to be very low, in such cases we go for nickel coating. So it depends on the application, performance, cost also plays a vital role. So that is why you have to understand what is the voice of the customer, which market you're going to address. Accordingly, you have to use the product, design the product. Otherwise, it will be either overspec or underspec. Hope I have clarified.
Yes, sir. Sir, I have one more question.
Yeah,
Sir,
sure.
what should be the insulation resistance for a pin-to-pin connector, sir?
Okay. So see, normally we look for 500 megohm. Okay. So, but it varies. If it is for a high voltage application or for a high temperature application, it would vary. But normal industry standard 500 megohm we test, a breakdown voltage we check. So that is where when I had shown in one of the slide, we connect a lot of insulators, rubbers, and all those things. In the assembly, there should not be any gap, air gap. If there is an air gap, or if the plastic material is weak, when you do an insulation test, it will fail. Every connector which rolls out of the industry will be 100% tested for insulation resistance.
Sir, in the chat box, they have asked one question, sir. Is
Yeah.
there any gradings or standards available for connectors, sir?
Um, see, there is no specific grading like that we don't have in industry. Okay, I would clarify, I would answer like this. Depending on the application, we define a product to get qualified. Either it could be an IEC or UL or military specification. So based on that, it gets classified. You don't have 1, 2, 3 like that. It all goes based on the application and what the qualification it requires. And there are connectors which doesn't go through any qualification also, but it may not be in an industry. Minimum UL qualification is what we look at because that is the safety standard requirement. Hope I have answered the person who had asked on the chat box.
Yes, sir.
Okay, if you have any questions, you can send to me later also. If I would try to address if, as you go through. Okay. If
So,
there are,
yes,
yeah.
sir. So
Go ahead.
it gives me an immense pleasure to deliver the word of thanks for this event to all dignitaries assembled here. I would like to thank our guest speaker, Mr. Suresh Kumar M, who honored this iTalks with his inspirational thoughts. I would like to thank our beloved professors, student office bearers, volunteers, and last but not the least, our beloved audience for making this iTalks as a grand success. Thank you once again, sir, for your valuable time to make this event successful. Lot many things in the area of defense and aerospace was taught to us. We as students have a great role to play. It's truly inspiring, sir. Thank you.
Thank you. And you can get connected through any of our links here, Facebook or Twitter or any of those things. And you can get more details on key.com. Thank you all. Thanks for your patient hearing.
Thank you so much, sir. So we'll surely get back to you in case we have any questions.
Sure. I think Swarabni has my mail ID. You can reach out. You can mail me. Whatever is, I can get back to you.
Sure, sir.
Yes,
Thank
sure,
you.
sir. Thank you, sir.
Thank you. And wishing you all the best.
Thank you, sir.
Thank you, sir.